Mm. Yeah. Me- Hey, yeah, I feel the feel like something until it's in the like therapy. It is that. So me have to go party and look at it. Cool. So good evening everyone. Or every two. Alright, so remember that Sunday the class that we missed was a tutorial, that is a problem solving class. But today we'll continue our instruction. We missed out on Monday because of the horrible weather that was, all over the island, especially western parishes and southwestern parishes. So these parishes had, quite a bit to do. And from the previous day, which was the Sunday, the internet was affected seemingly by the weather. I hope that it was really by the weather and the weather is fine today. So we will definitely have our class 100% today. Right, so today we'll be taking a look at the solution of simultaneous equation. Specifically, we'll be taking a look at the elimination method. We'll be solving a pair of simultaneous equation and we'll be going via the elimination method. So the method is what is going to be the most important thing for sure. So we'll pay attention more to the method than anything else because we can solve an equation already. We can do everything with the pair of simultaneous equations. The only thing that we have not mastered, well, some of the students may have mastered it already, but the only thing that I can say something seriously about at the moment is the elimination method because I did not do that. So there is no assumption made as to your proficiency, no comment about your proficiency as it pertains to the solution of a pair of simultaneous equations. Now, before the class begins, for those who are already here, we'll take a look at pretty much, something about what we'll be doing. And of course, I'm going to switch over to the daylight in order that we will not have this big bright spot and this one over here. That's preventing us from seeing what we need to see. Also, I will collect another black marker. All right, so let's see how bright this one is. For me, it's not bright enough. So I'm switching over to the daylight. Yes, so I'm switching over to the daylight. Over there is this bright spot. We see another spot right here. That's my computer screen. And then the one up here, I cannot speak expressly for that one. So let me move away my computer screen. Now that I've done that, then I cannot 100% account up here. We have quite a bit inside here. Or we should take one from tutorial 1 or one from tutorial 2. Let me go to tutorial 1. I think that we have a tutorial 1 here. Yes, we do. And of course, from our tutorial 1, what will we do? Oh no, this is a very old tutorial book that we have here. Yes, oh, but we can find it right here. So let us put that right in the middle of the board for everyone to see. If we beginning of it, right? So all right. So we have 8x plus 3y is equal to 35, and 2x minus 5y is equal to 3. 2x minus 5y is equal to 3. Of course, we need a brighter marker or an additional marker. I think I'll take an additional one. I have them all the way right here. Okay, let's go. Now, we have quite a bit to explain concerning, concerning the elimination method when we are solving a pair of simultaneous equations. Quite a bit to discuss. So we'll take a few minutes and discuss them right now. Now, the elimination method means that we have an equation, we have a pair of simultaneous equations in two unknowns. So we have two equations in two unknowns. Most methods of solving a pair of simultaneous equations will make an attempt to write, first of all, one equation in one unknown. So we have two equations with two unknowns, and our aim is to arrive at one equation with one unknown. In order to do that, we have to cause these two equations to interact with each other, because at any stage of the game we neglect one of them, then the solution will not be reflective of the requirements of both equations. So we'll have to cause these equations to interact with each other in such a way that we get one equation with one unknown. So invariably, this is what some teachers do. They eliminate the x. Usually they go directly to the x. So let us go straight to the x. If we're going to eliminate the x, then we need the coefficients of the x to be the same, or to be additive inverses. So we need them to be the same or to be additive inverses. So one quick method, now I'm not tying you down to a single method. One quick method that the teachers will use is that they take the equation at the top, which is equation 1, and they multiply it by the number that is down here, by 2. So they take the equation that we have up here, and we multiply by the number that is here. By so doing, if we multiply the entire equation by 2, we'll have 2 8, 16x plus 2 3s, 6y is equal to 70, and that is will be your third equation. Then what they'll do is they take the equation that is down here, which is equation 2, and they multiply that by the number that is up here, or the coefficient of the x that is there, which is 8. So they multiply that by 8. What do we get? 16x minus 40y is equal to 24. Please correct me if I make any mistake with the digits. So multiply this by 8, 16, 40, 24. Nice. Right. Now that the two x's, they have the same coefficient. The two values are exactly the same. So if you have two numbers, or two expressions, or two terms, 6x, is it 6x, 16x, and then you have 16x here. Let me write it a little bit lower. 16x there, and 16x here. What sign would you put between them in order to get 0? Because when you eliminate, alright, since they are exactly the same thing, when you minus one from the other, the result will be 0. So you put a negative sign here. This negative sign tells us that we need to subtract one equation from the other. And when you are subtracting, you may subtract in any order, but choose the order that is more in line with the way that you think. I am always a positive thinker, so I'm always thinking that I will subtract in such a way that the values are positive, or as much as I can be positive. So I will say equation 3 minus equation 4. When I say equation 3 minus equation 4, I will have 16 minus 16, and the x's will be eliminated. So it's 16x minus 16x, the x's are eliminated. Then I will say what? 6y. And I have to be careful here because of the negative sign. So it is 6y minus, not minus 40y, but minus negative 40y. So it is 6y minus negative 40y. Let me write it here. 6y minus negative 40y. And you know from your directed numbers that these consecutive negative signs will result in 6y plus 40y. So what we will have here is 46y is equal to, I think, is 46. So what we have done there, we are not solving the equation, students. We'll not solve the equation maybe until the next hour or next hour and a half. What we are looking at now is the elimination process. I'm looking at the elimination process because you can already solve the equations. So it's the elimination process that we are focusing on. So we will not go through the entire thing and solve the equation. So in this event, notice what I've done here is that I have eliminated the x's. Now, I'm going to eliminate the x's again, but I will eliminate the y's in the next presentation. So let us go. Don't worry, because we are going to start the lesson at the beginning. It is just that we have a few seconds, and I'm using the time to demonstrate something about the. So, some teachers invariably eliminate the x's. But I need you to be balanced. And I need you to take advantage of anything that makes this simultaneous equation, the pair of simultaneous equations simple, or the system simple. Let's go. Now, I'm not saying that this is simpler. No, I'm not saying it is simpler. I'm saying it's a different perspective. One, it has this simple approach that I'm going to take. Single approach, it will contain two different perspectives. So let us take a look at it. Now, while we just multiply the one up here by the one down here and the one down here by the coefficient there, that's what we have done. Now, I'm demonstrating now that it is not just for you to think in a narrow way to just eliminate the x's. You may also eliminate the y's if you please. if it is simpler. So if it is simpler, not that this one is simpler, but I'm just demonstrating it, that the y's may be eliminated. So let's go. So I'm going to take equation 1, and I'm going to multiply by, so we take equation 1, and multiply by the coefficient that is here. Or just multiply by 5. So let's multiply by 5. What do we get? Plus 15y, let me write the x better, plus 15y is equal to, what did we say we are multiplying it by? 5. So it is all of 5 of 35. So 235 is 70, another 235 is 70, 140. 140 plus another 35. What will that give us? Is that correct? So let us see. 5 into 17, that will be 3 times and 2. So that's right. Then, okay, this is your equation 1. Equation, 3. Then what do we do next? We take equation 2 and multiply by the coefficient that is up here, which is 3. So, whereas we just eliminated the x's, we are going to attempt to eliminate the y. 3, 2, so we're going to have 6x here. 3, 2, 6. Then, of course, 3, 5 is 15. So, it's going to be 3. This one is negative. And 3 times this. I hope it's just 3. And that is our equation 4. Nice. Now students, take a look at what we have here. We have these two. As a matter of fact, there, we have a positive 15y and we have a negative 15y. Now, if that be the case, what sign would we put between them in order that the result is 0? So when we eliminate them, the result will be 0. What sign do we put between them in order that the result is going to be 0? Or, just not limit it to a sign, what may we do to these two to make sure that the result is 0? Well, we can see that these two, they are 15, 15, but the signs are different. They have the same value, as you can see, but the signs are different. And of course, earlier on, we discussed the occurrence of numbers and even terms that are like that. And those, we call them additive inverses. So they are additive inverses. And what do we know about additive inverses? Since they are additive inverses, they will have a cancelling effect on each other when we add them. Additive inverses have a cancelling effect on each other by addition. So when we add them, the result will be 0. So because these will be eliminated, the two equations. So we have equation 3 and equation 4, and we are going to add them. This should be like this. So equation 3 plus equation 4, and what do we have? 40 plus 6, so this is 46x. And of course, because these are additive, equal to 35, and 2x minus 5y is equal to 3. Now we may proceed to eliminate the x's. And of course, we are generally taught to invariably multiply the number that we have here, this equation that we have here, by the coefficient of x here. That's what we were taught. So we're taught like, take equation 1 and multiply by the coefficient that is here. Then take equation 2 and multiply by the coefficient that is here. And of course, eventually, the x's will be in a state of readiness for elimination, because either they will be of the same value or they will be additive inverses. Now, solving a pair of simultaneous equations. So let's go. We are going to take equation 2 alone. So take equation 2 by 4 and we get what? So if you are going to take equation 2 and multiply by 4, why is it that, of course, this is an acceptable thing? Notice that we don't have a coefficient of 4 here or a coefficient of 4 here. Okay. Notice that we do not have a coefficient of 4 anywhere in this. There is no coefficient of 4. However, we can choose our approach from a common sense point of view by just using our common sense. Because our idea is not to multiply. That's not the aim and objective. The aim and objective is to get the coefficients to be the same or additive inverses. So we'll take the equation 2 and multiply by 4. When we multiply equation 2 by 4, what do we get? 8x minus 20y is equal to 4 3 is 12. And that is our equation 3. So even though we did not multiply by any of the numbers that are here, notice what happens. Notice now that we have what? 8x here and 8x here. That means what? We have the same values here. The x's are the same, and we may therefore go straight ahead and eliminate the x's. Even multiplying by a number that is not here. And you should be ready to do that if it makes it simpler. Notice that by doing this, we do not have to multiply the second equation. The first one. We don't have to multiply the other equation at all. So instead of having 2 new equations, a total of 4 equations, we only have 3 equations and our solution is shorter. We can do that because that causes the x coefficients to be the same. Now, we'll go now to our real lesson. Let me see. Which, of course, for the yes, we'll go to our real lesson, which, of course, for the most part, yes, which will, for the most part, use the same things that we have taken a look at, all 3 of them. But we will be more flexible. So let's go. We're going to go to the lesson. So, at this point, I'm going to say, for everyone who is here, good evening to everyone. Thank you for joining. Thank you for sharing. Thank you for liking. Thank you for telling others. And thank you for your, and thank you for your comments. All right. So let's continue. Where am I now? All the way to topic number 7, to number 8, as it is. Simultaneous equations. Let's go. (7x plus 2y is equal to 12. I think I could put it out somewhere. Seven, until that is at the same spot. 7x minus 2y is equal to 12, and that is your equation 1. The equation 2 is 5x plus 3y is equal to 10. 5x plus 3y is equal to 10, and that is your equation 2. And at this early stage, students, we are not solving the pair of simultaneous equations. We are going to eventually do that, but you can solve equations already. So we should not be so hung up over solving equations. We are just going to be looking at the elimination method. Now, the elimination method is a procedure that reduces the system of simultaneous equations to a single equation with one unknown. And that is what, for the most part, methods of solving a pair of simultaneous equations will do, as long as it is not a matrix method. Even matrix method, well, Kramer's rule is a bit different, but you have methods in matrices that also make use of the whole concept, the whole idea of the elimination method in solving a pair of simultaneous equations. Now, what we want to do is to eliminate either the x's or the y's. That is what we want to eliminate. We want to eliminate either the x's or the y's. In order to eliminate them, we try to get them to be the same. For example, we get 5 here, 5x there, and 7x here. But what we want them to do, we want them to have the same coefficient. Right? So we need to have them with the same coefficients. So take a look at my approach and tell me what is wrong with this. So if I have a system of simultaneous equations like that, I want the coefficients of x to be eliminated, or the x's to be eliminated. So I'm attempting to get the values of x to be the same, the coefficients. So let's see. Get the coefficients to be the same. I just erase this one and put a 7 there. And know that I have them being the same. What is wrong with that? What is wrong with that? Can anybody tell what's wrong with that? All right. Well, I will not attempt that. Let me see. Well, pay attention to this and let's see how it works. Why is it that we cannot just erase, what was this? A 5. That's what the original system of equations was like. That's the original system. Right. Why is it that we cannot just do this? And just erase it and put a 7 there so that they can be the same. Why is it that we cannot do that? Change this equation. Yes, it will change this equation and consequently change the entire equation and consequently change the entire system. Right. Okay, so I hope that you can see the link here. Both students who are on YouTube and on TikTok, I hope that you can see this link. If I'm encountering too much difficulty, I'm going to change over. Okay. You cannot just say that it is just wrong and you don't have any explanation for that. Because you must always be prepared to give a reason. To give a reason for whatever position you take. For example, you will be in a debate with someone. You say something that is correct. Because although you are right, you cannot defend what is right. And you cannot give a reason for the position that you have taken. Right. So you need to be able to defend yourself. Now, it could never be right, because by doing that, you are changing one of the original equations. That's all. And if you change one of the original equations, then you are automatically changing the system. All right. Now, this is what the teacher will say that you should do. You should take equation 1 and multiply that by here. So take the equation that is here, which is equation 1, and multiply it by the coefficient of x of that equation. So let's go. So we're going to take the entire equation and multiply that by 5. So by doing so, 7 5s 35, 2 5s 10, 12 5s 60, and that is your equation 3. And of course, you want to do it vice versa. So you will take the equation here, which is equation 2, and you're going to multiply that by the coefficient of x that's in equation 1. And what do you get? You take this, so you have what? Equation 1 multiplied by 5. Equation 2 multiplied by 7. So here, you'll have 5x multiplied by 7, you have 35x. You have what you want here because they are exactly the same. Then you say 7 also times the 3, so 3y equals 7 times 10, 70, and that is equation 4. So now that you have done that, the x's are the same. The coefficients of the x's are the same. So since the coefficients of the x's are the same, you may go straight and replacing it with a 7. Read that was wrong. So what I've done now, I put the 5 back to the original equation and I multiply the equations like that. Now, I have 2 questions for you. 1, why is this step legitimate? I've taken the entire equation and multiplied by 5. Why is it that I may do that? The topic is the solution of simultaneous equations. And we have many methods that we may use, but we are using the method of elimination at the moment. So we are solving by elimination. As a matter of fact, we are just looking at the elimination process. We are not solving the equations as yet. So I want you to have a very good understanding of the elimination process before we go straight ahead and solve the systems. Let's go. So here's the question again. Why is it that I may take an entire equation and multiply by 5? It is perfectly legitimate to take an equation and multiply by 5. Why is it perfectly legitimate to do that? Anybody has an answer? Why is it that I may do that? Okay. Let's see if you're, by the time I write this on the board, if you'll be ready with an answer. Let's say you have an equation like 3x is equal to 30. No one is ready. Okay, let's ready for this then. 3x is equal to 30, then x is equal to what? What is x equal to? If 3x is equal to 30, what is x equal to? Perfect. X is equal to 10. Okay. Let us take this same equation and multiply by 2. So 2 times 3 will be 6. So we have a 6x here equals 60. Because we're multiplying the equation by 10. If we multiply the equation by 10, we'll get 6, not by 10. If we multiply the equation by 2, we'll have 6x is equal to 60. So if 6x is equal to 60, what is x equal to? If 6x is equal to 60, what is x equal to? I see that again. 10. So what do you realize? You should realize that if you multiply an entire equation by a single number, it does not affect the result of solving the equation. So if you take an entire equation, multiply it straight through by any number, it does not affect the solution of the equation. Therefore, the system of equation is not changed by multiplying any of the equations all the way through by any number. So it is perfectly legitimate to take the first equation and multiply by 5 because it does not affect the equation. The integrity of the equation is not affected. Only the numbers are different because you just multiply by 5. The next one, the same. It does not affect the whole result or the integrity of it remains the same. So the equation here that we have here and those that we have here, they are logically identical. Just the numbers are different, they are logically identical. Therefore, by doing so, we have not changed any of the equations per se, and we have not therefore changed the system. The system remains the same. Okay, that's a lovely question. Why 5? Couldn't it just be by any number? What you are doing a vice versa switch. That's what you are doing. Because, let's look at this. 5 up there, use 2 different numbers. 8 up here, and 3 down here. So, in order that the 2 numbers will be the same, because what you want the 2 coefficients to be exactly the same, or you want them to be additive inverses. In this case, they will be the same. So if you want them to be the same, what do? You take the number from down here and multiply it up here. So you say 8 multiplied by 3 is equal to 24. And then you take the number that is down here and you multiply by the number up here. So 3 multiplied by 8 is equal to 24. I hope that you are seeing both of them. That's what you have done. You have done that in order that the 2 numbers will be the same. Let me see. Right, you can see them, right? So you do that in order that they may be the same, because when they are the same or they are additive inverses, then you may go straight ahead and eliminate. For sure, we'll see that before we are through this evening, that instead of multiplying, if the numbers are large, or even if they are not large, but you just want them to be more manageable, you can divide. Right? So I usually divide 2. Right? And you will see Yes, and we'll see the whole division process and the pros and the cons. So does that answer you? Why we multiply by 5 though? We are taking the number up here and take the number here, multiply by 5, and then take the one down here and multiply by 7, just like we did right there, to get the 35, 35, or in this particular case, the 24, 24. Right. And of course, we do not have to choose numbers that are there, as we will see later. Okay, all right. So let us eliminate now. Since the 35x, we have a 35x and a 35x. We want a 0. So we have 35x here, 35x there. We need a 0. So in order to get the 0, we will have to put a sign here, which is a subtraction sign. So we will subtract one equation from the other. These 35, we're going to subtract one equation from the other. So do we say equation 3 minus equation 4, because we can say that, or we can say equation 4 minus equation 3. I'm going to do the one that you say. Do you say equation 3 minus equation 4 or equation 4 minus equation 3? Use any? All right, well, since you have no preference, when I do mine, then make sure that you don't tell me later that I should have done it another way. No, I'm not waiting any longer. So what do we have then? We'll say equation 4 minus equation 3. And someone should have correct. Let me look at this. Multiply this by 5, 35, 10. Down here, multiply this by 7. So I'm going to say equation 4 minus equation 3. So of course, 35 minus 35 will be eliminated, and 70 minus 60 is equal to 10. What about what we have here? 21 minus negative 10, because we're subtracting. So it is 35 minus 35, it is 70 minus 60, but here it is 21 minus negative 10. So 21 minus negative 10. What does that give? What is the result of 21 minus negative 10? Let me have it. So far, I have not seen the correct answer. What is 21 minus negative 10? (31) is correct. From your directed numbers, this is the result, and that's equal to 31. So what we'll have then, the x's will be eliminated, and we have 31y is equal to 10. Correct. Now, bear in mind that we are not solving the pair of simultaneous equation at the moment. We are actually looking at the elimination process, and we are going to take a look at this system again. So we have 7x minus 2y is equal to 12. That looks too wide. 7x minus 2y is equal to 12, and that is equation 1. Then we have 5x plus 3y, and that is equal to 10. And that is your equation 2. Now, for the person who said why we would do that, I need you to pay special attention. Now, although some teachers invariably eliminate the x's, we are going to take an approach now that we are going to eliminate the y's. So, by so doing, we have to do a switch again. Minus 2. So what do we say? We take equation 1, and because we are eliminating the y's, we multiply by the number that is down here. Multiply by 3. So we take the equation that is here, which is equation 1, and we multiply by this because we are eliminating the y's. So what do we have? 21x minus 6y is equal to 36. And that is your equation 3. Then for equation 2, you take the equation that is down here and you multiply by the coefficient that is there. So you multiply by a 2. Now some teachers will multiply conveniently, and I'm going to discuss that in a few seconds, but let us finish this. 3 times 2, and what do we get? Equation 2 times 2, so we're going to take this equation, all of this, and multiply by 2. So 5 2's, 10x. And multiply by 2 here, we get 6y. And multiply by 2 here, we get 20. And that is equation 4. So we are, at the moment, attempting to eliminate the y's. And what do we notice with the y's? A negative 6y and a positive 6y. What do we say? Or what do we know? I think that you know numbers are terms that exist like this, and we have a special name for them. Yes, we have a special name for them. Yes, we are doing the same thing, not just with different numbers. We are doing the same thing, but in the first case, we use the coefficients of x because we are interested in eliminating the x's. Then in the next case, we are interested in eliminating the y's, so we use the coefficients of y. Sure, we did the right thing. We did the x's because we wanted to eliminate the x's. Then we did the y's. Now, this is what we are doing the y's, so we are eliminating the y's. Now, students, do not forget this, that when they are the same terms or the same numbers, but the signs are opposite, they are additive inverses, and additive inverses will have a cancelling effect on each other when we add them. So because of the additive inverses, that will cancel when we add them. We will add the two equations. So we will say now, equation 3 plus equation 4, and the order does not matter. Equation 3 plus equation 4. 21x plus 10x, that's 31x. I can write it pretty much anywhere because the y's are additive inverses and are eliminated. And then 36 plus 20 will give us 56. So there we have the x's eliminated there, and now we have the y's eliminated. My question to you is this. Yes, my question to you is this. This approach and this approach, I'm asking you, which one do you prefer? And you should give me 2 reasons. Now, of course, I have my preference and I have my 2 reasons. So let me hear or see any answer coming up. Now, Let me see your answer coming up now. Which one of these approaches do you prefer and why? You prefer the additive inverses, me too. I prefer the one with the additive inverses, of course. So, let's go to it. Let's go for the first one. Do not forget that in the first case, when the subtraction was supposed to take place, a lot of students made mistake in the answer. Some have negative 11, some have 11. Because of the difference in signs. And we are subtracting. And we ended up with a lot of incorrect answers. So in cases which we are required to add numbers, not add, in cases in which we are required to subtract, if when we are subtracting we have many different signs, then it is more challenging than just to add. So when we have the additive inverses, we just add. So I prefer just to add, because by subtracting, in a case when we have many numbers with their signs, we might encounter a greater challenge. So that is one reason I prefer this one. I prefer it because of the additive inverses. Any other reason to prefer this one? Any other reason to prefer this one? In that case, if you look at it, in this case, we are multiplying by smaller numbers. The other set of numbers are not outrageously large by any means. They are not outrageously large or outrageously larger, but we are multiplying by smaller numbers. In some cases, in the long run, maybe when you are doing college algebra or abstract algebra, well, abstract algebra does not contain many numbers. But when you are doing algebra at a higher level, you may consider to simplify your problem by multiplying by smaller numbers instead of large. Okay. So that's my take. I prefer this one because the additive inverses makes it just easier to add, and also I prefer to multiply by smaller numbers. Fine. Now let us take a look. We are looking at the elimination process. Same way, we are continuing with the elimination process. We are not solving equations as yet. We'll solve equations eventually, but we are looking at the elimination process. So I'm going to call this one A and then call that one B. Let's go. So this one is here A, this one I'll call it B, then I'll go to C. C? Alright. So what is for C, if I see anything? Yes, 3x plus 2y is equal to 15. Look at this one now. 3x plus 2y is equal to 15, and that's equation 1. Equation 2 is 5x plus 8y is equal to 10. 5x plus 8y is equal to 10, and that is your equation 2. What do you say that we should do? What do you say that we should do? What do you say that we should do? It will invariably, it will work if we do what the teacher says. Invariably multiply by the coefficients that we have here. That will work. But when you're solving a pair of simultaneous equations, you need to go for what? Time and space efficiency. Multiply by 3 and 5. That's nice. That will work. But look at this and tell me if it will work. Equation 1 multiplied by 4, 12x over. Equation 1 multiplied by 4, I get what? 12x plus 8y is equal to 60. Will that work? Will that work? If I just take one equation and multiply by 4. Take one of the equations, just multiply by 4. Not multiplying the other. Will that work? Why is it that it will not work? Why is it that it will not work? Is it that we have to multiply by numbers that we have up there? Or that we have to multiply the maximum number of times? Why is it that it will not work? Okay, do you see, let me just X out the equation that is not supposed to be there. The system, since we use equation 1, notice that we use equation 1. Because we use equation 1 is out of the system. So the new system consists of these two equations, as they are. Look at them. This new system consists of these two equations. Is that okay? I'm measuring. What do you say about that? Notice that these two coefficients of y are the same. So students, you can use your common sense. You can be as observant as you require. You pay attention to detail. And you know that all that we need is two of the coefficients to be the same or to be additive inverses. And then we can do that with the greatest level of efficiency. And the greatest level of efficiency will be attained if we multiply just equation 1 by 4. And by so doing, we have 8y and 8y. So it is not all about multiplying. No, that's not the objective. The objective is to get two of the coefficients to be the same or to be additive inverses. So the objective is neither to multiply, but if multiplication does it, then go straight ahead and multiply. And by all means, multiply by numbers that you see there. But I'm now demonstrating to you that you don't even have to multiply by a number that is there. Because your objective is not to multiply, and your objective is not to use a number that is there. Your objective is to get the coefficients of x or the coefficients of y to be either the same or additive inverses. So we may continue. So since they are exactly the same, we need to subtract. So do we say equation 2 minus equation 3 or equation 3 minus equation 2? Do not lose focus at any step of the way. Always exercise presence of mind. So do I say 3 minus 2? That's what I would do, because I see that 3 has the larger numbers, and when I subtract, I will just get positive numbers. So 3 minus 2, what do I get? 12x minus 5x is 7x, and 60 minus 10 is 50. And the x's, not the x's, the y's are eliminated. Of course, you're going to see that 8y minus 8y is 0. So the y's are eliminated, and this is what we have. So there you go. We are already finished with the elimination process. All right, let me see if there's anyone who can shorten the elimination process with this one. So let's put it right here. let me call it D, and let me call it D, or what I should do is write it with a different color so that I can write it closer. You go over there, here it is. So I'm going to write it with a different color just so that I can write it closer. D 2x plus 6y is equal to 14. 2x plus 6y is equal to 14, and that is equation 1. Equation 2 is 5x minus 3y is equal to 5. 5x minus 3y is equal to 5, and that is equation 2. Okay, go straight ahead and tell me what I might do in order to get the coefficients to be the same or additive inverses. Let's go. Lovely. Multiply by what? Multiply a number that will give the same as number or number. Come on. Just look at this. All right, well, I'll go straight ahead. Equation 2 multiplied by 3. Is it? No, equation 2 multiplied by 2. So equation 2 multiplied by 2. What do I get? 10x minus 6y is equal to 10. And that is equation 3. There you go. So what do you notice, if anything? Thank you. It's 3. For sure, it's 3. It's 2. So we want, if you look here, you see a 6. You look here, you see a 3. You just say 3, 2, 6. Well, it's just easy as that. If you look here, 2 and 5, then there's no easy multiplication. You'll have to multiply this one by 5 and then this one by 2. But when you look at this, you see 6 here and you see 3 here. Then you know that you can easily cause this to go to 6 by multiplying by 3. Sorry, by multiplying by 2. So you just multiply this by 2 and you're on. Is this a girl's father from my school? Of course, if you attended Chetud Memorial, then yes, it's the girl's father from your school. Right, yes. Alright, so students, remember now that we took equation 2, and because we use equation 2, it shouldn't be like that, it should be like this. Equation 2 multiplied by 2. Right. And because we use equation 2 is the one that is out now. So the equations in the system are these two. These are the two equations in the system. And what do you notice? You should notice that they are right here. Or even more importantly, they are additive inverses. So right. Even more importantly, they are additive inverses. So because they are additive inverses, we go straight ahead and add the two equations. Now the two equations in the system are equation 1 and equation 2. So those are the two equations in the system. Equation 1 and equation 2. So equation 1, sorry about that. I was just a little bit disturbed just now. So the two equations that remain in the system are equations 1 and 3. Equation 2 is out since we used it right there. So equation 2 is out of the system and we have 1 and 3 left. And of course, when you look at equations 1 and 3, we see the y's are additive inverses. They will be eliminated by addition. So we say equation 1 plus equation 3. So we add them. And when we add those two equations, what will happen? Notice that the additive inverses, which are the y's, will be eliminated. And we have what? 2x plus 10x. 12x equals 14 plus 10, that's 24. So that's it. In that case, the y's are additive inverses and are therefore eliminated by addition. Okay, they are eliminated by addition. Let us take the same system. Let us take the same system and put it to E and say 2x plus 6y is equal to 14. And that is equation 1. And then we say equation 2 will be what? The same thing. 5x minus 3y is equal to 5. And that's your equation 2. So it is the same system that we have there. The same system of equations that we have there. What do I say this time around? Right. So now, if you look at these two equations, again, now students, from time to time, you will get a system that does not lend itself to simplicity. So you'll have to go out a number of times. So in this case, we have what? 3y here, and we have 6y here. So we see that the 6 is 2 times 3, and the 3 is half of 6. So we may then take the first system, which is starting on the first system, the first equation, equation 1, and divide it by 3. Division sign is far. Equation 1 divided by 3. By 2. So equation 1, and we're going to divide that by 2. So take a look at that. If we multiply this number here by 2, we get 6. It's as easy as that, and we did that right here. Also, if we divide this number by 2, you'll get 3. So we'll have additive inverses nonetheless. We are doing it like that now. So equation 1, we're going to divide that by 2. 2x divided by 2 is x. 6y divided by 2 is 3y. And 14 divided by 2 is 7. And that is equation 3. There you go. What do you have there? Notice that we said equation 1 divided by 2. So the equation that we use is equation 1. It is out of the system. And the equations that are in the system will be equations 2 and 3. And surely, these two are additive inverses. So you may add the two equations. So equation 2 plus equation 3. And what do we get? 5x plus x is 6x. Of course, the y's are additive inverses and are eliminated. And then 5 plus 7 is equal to 12. So if you look at it now, you'll see 12x equals 24. If 12x is equal to 24, what's the value of x? 12x is equal to 24, what's the value of x? What I'm saying here is that, or demonstrating here is that you do not have to program yourself to multiplication. Multiplication is always easy if you look at it generally, because while multiplying, you're not encountering any fractions. And you don't have that danger of encountering a lot of fractions. But when you divide, you might encounter fractions. So in this case, what I've done, I'm demonstrating now that you don't have to multiply all of the time. Division will work too, or has the potential to work. And by dividing, you are still using a legitimate method. One person is saying that I am lost now because you are tying down yourself. So when somebody presents to you one way of thinking and you think you understand, and the person presents to you a different way of thinking, then you are reluctant because your first way of thinking is not something that you want to adjust. You want to stick to that one way of thinking so that you become tunnel visioned. So you will not be able to see things from many different perspectives. And so you will not be able to approach your simultaneous equation from many different perspectives. Therefore, you will not be able to choose a more efficient technique. So at all times, you will just be doing the same thing, the same way all of the time. So when you go to the examination and you see a pair of simultaneous equations, by the time you finish solving the pair of simultaneous equations, my students would have been finished with the entire exam. Because you are prepared to multiply by 2, then multiply by 5, then multiply by 5, and then multiply by 2. That is what you are prepared to do. No, I'm prepared just to multiply by one number. Then after that, you need to be prepared. You must be prepared to subtract. You must also be prepared to add when you have additive inverses. So it is a whole spectrum of things that you should be able to do. But you just want to do one of them alone. And as soon as you get this one alone, then you're going to use the one to do everything in life. And that is your approach. And needless to say, that if you are satisfied, I'm saying, prepared to eliminate x, prepared to eliminate y, prepared to subtract when they are the same, prepared to use additive inverses when they are different, prepared to multiply, prepared to divide. Or when do you just divide or multiply? All right, look at this situation where this is a simple multiplication situation. Okay, I will answer the question in a minute. It is best to answer with an example. It is best. I think I could do it, you know. It's best to answer with an example. So let us go to the next one. 4x minus 5y is equal to 13, and that is equation 1. So let me see if we can see that one on the screen. All right? Maybe I do not have 100 left, so I think that I'll put it down here. All right. So let us take a look at that one. Let's see. We have 3x plus 2 is 1510. The one with the 1510, we have that one right here. Where am I seeing it? 13. With it, next one is 13.5. Okay, this one, the E, well, I'm calling it the F. I'm going to put that on the board now. So that's it, right? So I'm going to put F and call, say, 4x plus, is not 4x plus, 4x minus 5y is equal to 13. And that's your equation 1. Then I'm going to say 2x plus 3y is equal to 15. 2x plus 3y is equal to 15, and that is equation 2. So I'm answering now the question, when do you know when to divide from when to multiply? Somebody please tell me what to do with this system. For greatest efficiency, what do we eliminate and how do we eliminate it? Let's go. What do we eliminate and how do we eliminate it? You eliminate x by? I'm going to eliminate x, so you are correct on that one. So eliminate x by doing what? Eliminate x by eliminate x by okay, all right. So you're going to eliminate the x's by dividing by 2. I would eliminate the x's, but I would not divide by 2. Right, so yes, I would eliminate the x's, but I would not divide by 2. For sure, I would eliminate the same thing. Now, why is it that I would not divide by 2 here? Why I would do it here? Now, look at this. Because I see the 3 and the 6, it is easy as 3 to 6 to eliminate. And it's also as easy as 6 divided by 2 to give 3 to eliminate. It's as easy as that. But while doing that, if I come here, I would not divide by 2, although it is as simple. And it's similar to that. I would not do that because when I divide by 2 here and here, I would get fractions. If I divide this by 2, I will get the 2 that I want. But I'm going to get 5 halves and 13 halves, or what you will say is 5 over 2 and 13 over 2. Or I might get 2.5 and 6.5. So I wouldn't do that because this one will run me into fractions. So I would multiply instead of divide. The reason for doing it here, of course, you saw that by dividing by 2, I did not encounter any fractions. So I'm prepared to do it there. All right, so let's go. I think that you're onto that. So we'll just say equation 1, not equation 1. Equation 2, yes, is equation 2. Equation 2 multiplied by 2, and what do we get? 4x plus 6 Equation 2 multiplied by 2. 4x plus 6y is equal to 60, and equal to 60, and that is equation 3. The equation that is out is equation 2. So yes, we multiply. Alright, yes. So we multiply. Yes. So we multiply equation 2 by 2, and of course, after multiplying equation 2 by 2, we know that equation 2 is out of the system. So multiply this by 2, we get what? 4x plus 6y is equal to 60. And we have these two left. So because these are identical, students, you have to remember that, or use your common sense on it. Because they are identical, we'll have to subtract one from the other. They are not additive inverses. When they are additive inverses, we add them. When they are the same, we subtract. So do we say equation 3 minus equation 1, or equation 1 minus equation 3? What do we say? Do we say equation 1 minus equation 3, or equation 3 minus equation 1? All right? A few more seconds. All right, let's go. I would say equation 1 I'd say equation 1 minus equation 3. All right. So let's continue. Equation 1 minus equation 3. No, that's not my intention. Lovely, I see equation 3 take away 1. I'm going to go for that. Equation 3 minus equation 1. When I say equation 3 minus equation 1, I say 4x minus 4x is 0. What about this one? 6y minus negative 5y. What about that one? 6y minus negative 5y. 6y minus negative 5y. What do you say about that one? Exactly. Because this will turn out to be what? 6y plus 5y. And that will give us 11y. And then, what do we say? I doubt very much that the system of equation is exactly like we have it right there. Let me take a look at it. And see what it really should be. 4x minus 5y is equal to 13, and 2x plus 3y is equal to 5. All right. So let's look at this now. Equation 2 multiplied by 2. What do we have? This should not have been 15. It should have been 5, is it? 2x plus 3y is equal to 5. It should have not been 15, but 5. So this should have been 5. Right. And of course, if we say 3 minus, it would be 10 minus 13, so that would be a negative 3. It should not have been 15, but 5. No problem. Of course, it does not affect the elimination inside here, but the figures there will just change, and that's all. All right, so Let's do the last one in the elimination. Quick to tell me what I should do with this one. Tell me what to do with this one. Be quick. (4x plus 11y is equal to 20, and that's equation 1. So 4x plus 11y is equal to 20. The next one is x minus 11y is equal to negative 10. Tell me what to do with that one. If you can see, let me see if it is visible. Yes, it's visible to me. It's just that which one of these signs look too invisible? One of the negative signs did not show so bright. Let me take a look at it now. So what do we do now? What do we do? So our elimination will be very quick. All right. What will we do in order that the elimination process will be very quick? Times by, that's a very good move. Just multiply equation 2 by 4 and the 4s will be the same. That's a very good move. Excellent. But may I have a better move than that? Students, someone please give me a better move than that one. That one is excellent. But I want one that is a little bit better. Okay, because of the additive inverses that we have here, we may just add what? Equation 1 plus equation 2. The additive inverses are here already, so we don't have to do much with that. We go straight ahead and say this is equal to 10. So what do we do now? Yes, I'm going to go on the board again, and I am going to do examples of the solution of the pair of simultaneous equations now. So we have looked at the elimination process without solving the system. Now we are going to solve the system by making use of the elimination process. Let's go. I have to use a second eraser so that it is more time efficient. Ready? 1. Let's call this one number 1, although it's not really number 1 there. X plus y is equal to 3. X plus y is equal to 3. And 3x plus 2y is equal to 7. 3x plus 2y is equal to 7, and that is equation 1, and that is equation 2. What do you say that we should do? So this variety of options. That problem lends itself to a variety of options. Let's go. What do we do with that system? All right, since no one is ready to give an answer, I will give an answer. Notice here that we have an x here, and we have 3x here. So to get 3x here, all we need to do is multiply this by 3. So we'll just get 3x, and the x's will be eliminated. Also, y. And then we have 2y here. So if we multiply this one by 2, so which one should we multiply by? Do we multiply by 3 or we multiply by 2? Go for y. All right. Use 2. By using 2, of course, although there's no big disparity, you'll be using a smaller number. But let's do it. It's nice. Equation 1 multiplied by 2. And what do we get? 2y is equal to 6. I'm going to put away this marker for good. It's pale. And what I'm going to do, I'm going to experiment with it and see if it is right. Let's go. So that one is equation 3. No, it's not writing brighter. Just a little. Right, so that's equation 3. Notice now that you have 2y with 2y. Do we add or subtract? Do we add or subtract? So my question is, are the students hearing me? If you are hearing me, say yes immediately. If the students are hearing me, say yes immediately. Okay. Okay, thanks. All right, no problem. All right. So let's continue. If you notice that the y's are the same, so do we subtract or do we add? The y's are exactly the same. Do we add or subtract?